Hey folks, welcome to Compound Inequalities, where we're putting stuff together. So to start out, I wanted to revisit our good old problem from talking about the elevation of Utah. Now, if you remember from before, we said the elevation in Utah is at most 13,538 feet. And so what we said there was, okay, if I let, I think we said E could be our elevation or something like that. And always good to define the variable and how we're measuring it. Elevation in feet, it looks like. And we said, okay, so the elevation in Utah is less than or equal to 13,538. There we go. And so what we did to mark that is we had 13,538 somewhere on here, and we marked it, and we shaded everything that is less than or equal to 13,538, and we indicate that this keeps going to the left. Now, maybe you already see an issue with this, with my number line. If I just keep going and going to the left without a bound, that maybe doesn't quite seem to fit right, because there's actually a low point in Utah. And so here we are contrasting it. We are saying the elevation in Utah is at least. So in this case, we're saying it's greater than or equal to 2,178 feet. I'm not sure if you've heard of this Beaver Dam wash. I did not know this. This is the lowest point in Utah at 2,178 feet elevation. So to graph this one, I'm graphing the elevation, everything above 2,108. These are counting by 1,000s. This would be 0. Usually it's nice to have 0 on my number line. So this is 1,000, 2,000. So right about here is where Beaver Dam is. And this one goes on and on and on. And I would shade to show greater than or equal to. I would shade everything to the right of the boundary point here. Now, maybe you see an issue with this. Yeah, I hope you do. We've surpassed Kings Peak, and that's the highest elevation in Utah. So what we probably would want to do is combine these two into a graph that shows both of these together. And so this graph is shading all the possible locations in Utah. If you're in Utah, you're somewhere in this purple region, which would be between Beaver Dam and Kings Peak. So if you tell me you're in Utah, I know you're at least in this range. So this is kind of a way to say the range. So we actually write a statement, something like where the elevation is greater than or equal to 2,178, and here's kind of the key word, and the elevation is less than or equal to 13,538. So that word "and" is kind of critical here. We're saying that we need to fulfill both of these. We're combining these two graphs and saying our solution set is what works for both of these. And while we're looking at it, there's a way to write this, and it's really convenient because we're saying that the elevation is between these two values. And works out really nice when you put the least number on the left here, 2,178. Notice this statement, I just used the symmetric property of inequalities to rewrite it. But now I can say, and it's also less than or equal to 13,538. I think both of these ways to write it would be helpful to have in your notes. Awesome. Okay, well, let's look at another problem. So this is a way to say the solution set is between these two values. So I want you to see that too. Okay. Hopefully you're not too hungry. Lunch is coming up. It's pizza time. I used to work at a pizzeria. The freezer was quite cold, and the oven, you could burn yourself. Careful. So we got a little bit different situation here. So here, let's see, I'm going to use blue for the walk-in freezer. So now when food is kept in a freezer, it has to be below a certain temperature. So in this case, we're going to look at Celsius. So maybe I want to use T for the temperature. And what we're talking about is the temperature around the food. And it looks like we're going to measure it in degrees Celsius. The freezer has to be below -17. I'm counting by tens here. So I'm going to have an open circle. It's got to be below that. It can't be equal to it. It's got to be below it. -17.1, we're good. So the walk-in freezer, whatever it is, it's got to be below -17 degrees. So I'm shading everything to the left of -17, and I could write T is less than -17. Great. Okay, now there's an oven to cook the pizza. The temperature in the oven is above... Oh, it looks like I messed that up. Sorry about that. That was supposed to be a left parenthesis. Above 200 degrees Celsius. It's hot in there. The temperature needs to be greater than 200, and we show that by marking a open circle and shading to the right of 200. Of course, there's probably a limit there. We don't want to burn the pizza, but we're going to say for it to cook properly, we're just going to put this limit on it so that we make sure it hits that level. It's got to be above 200 degrees. And of course, there's limits to all of this stuff. But what I want you to see is how these graphs could be put together. The temperature that the food experiences in the pizza restaurant. So what I'm saying here is from the freezer directly into the oven. There's no in between, all right? It's either less than -17 or more than 200. There's no in between. I know I'm stretching it here. Bear with me. So this one, we're going to say, okay, T is less than -17. And here's the critical word here, or T is greater than 200. So we're putting these together, and you can see just from above, we just put them on the same graph. And that's it. And now we're saying in the solution set is in either of these inequalities. So the pizza could be in the freezer where it's less than -17 degrees, or it might be in the oven where it's greater than 200. Again, it goes right, there's a slot right from the freezer right into the oven. There is no in-between temperature. I know there's some issues with that, but bear with me. I want you to see it's definitely hard to come up with a scenario for this kind of inequality. So again, we're joining these inequalities together. And these are what we call a compound inequality. It might be worth noting in your notes here what a compound inequality. It's just joining two inequalities with the conjunction and or. So let's look at what this looks like. So here I was thinking you click on the X here, and hopefully that will let you insert an equation. I want you to write that X is greater than or equal to 2 is what that's saying. Okay, and this one's saying X is less than, or actually just less than 5, not equal to. We have the open circle. And so we have that X is greater than, I'm going to rewrite it over down here. X is greater than or equal to 2, and X is less than 5. We can also write it like this, where we say X is greater than or equal to 2 and less than 5. Notice I'm writing it from least to greatest. As long as you do that, it will always look like this as one string of inequalities here. That's kind of the common way to write it if we can. Okay. So this is a compound inequality using the word and, where it has to satisfy both solution sets. It has to be greater than or equal to 2 and less than 5. And think about numbers that would fit in that category that are both greater than or equal to 2 and less than 5. We have 3, 4, 3.5, pi, all those numbers in between 2 and 5. Okay. Compound inequality using OR. So we have X is less than negative 2 here, X or equal to. X is greater than 1. So we end up with this statement, X is less than or equal to negative 2, or X is greater than 1. Notice with OR, we have to write it as two separate inequalities. We're not going to string it together like we did here. If we did, it doesn't work. It doesn't make sense. Notice with the AND statement that this works. 2 is less than X, which is less than 5. 2 is less than 5. If you get some inequality, notice what... I'm nervous to write this down because I don't want you to make this mistake. If I write this, that X is less than or equal to negative 2, and X is greater than 1, this is an AND statement, and nothing works here. There's no number that's less than negative 2 and greater than 1. And notice this string. We're saying negative 2 is greater than 1. That's not true. Do not write it like this. I hope you saw that. This has to be written like this as two separate inequalities. This one can be written as two separate inequalities or a string like this. So let's practice just a couple problems. So here we have our two inequalities. M minus 2 is less than negative 8, or M divided by 8 is greater than 1. Try to solve this. Pause the video. Check after you solved it. Did we do it the same? Okay, so this is just two inequalities. We're just going to solve it by doing one step at a time. M is less than... I add 2 to both sides to get an equivalent inequality, is less than negative 6, or on this one, I would multiply both sides, multiplicative inverse to get M alone, and I get M is greater than 8. That's kind of a good indication that I have OR here, that I end up with this gap in the number line. So notice negative 6 right here, and I shade to the left. M is less than negative 6, like negative 7, negative 8. or m is greater than 8, so everything works that's greater than 8. 9, 10, 12, and so on. And so notice that was just with two inequalities. We join them on the same number line. This is my solution. And it's just really two inequalities. So same thing here, except notice I have an and statement. So x plus 8 is greater than or equal to 9. Go ahead and pause the video, see if we come up with the same thing. Okay, I would subtract 8 from both sides and get x is greater than or equal to 1. And for me, I kind of write this and statement so I don't forget it. It's part of the solution set. And x divided by 7 is less than 1. Multiply both sides by 7. X is less than or equal to 7. Okay, so notice what I have here. If I graph these inequalities, I got that going to the left, this one going to the right, and I really shouldn't have these arrows anymore because it needs to fit both solution sets. And so it should look something like this, where it's going from 1 to 7 and everything in between there. Notice we can also write this solution set as x is greater than or equal to 1 and less than or equal to 7. That either one of these is both acceptable ways to write the solution set. You decide. But the graph should look like this, where it's an interval from one point to another. It does not go infinitely in either the left or the right here. Of course, if we had a different situation like all real numbers, then yeah, of course that would shade the entire number line. Okay, I wanted you to see an inequality like this, where it's given to me as a string. This is an and statement. This is saying 7k plus 6 is greater than negative 50, and 7k plus 6 is less than negative 8. Notice what we would do to solve this. I subtract 6. I actually am doing the exact same thing. So one way to solve this one that's kind of a string is just to treat it like two inequalities, but we can kind of do it all at once. So we get 7k is greater than negative 56, and we get that 7k is less than negative 14. And notice what I get here. I actually get that same thing. Negative 50 minus 6 is negative 56, is less than 7k, which is just written a little bit differently, is less than negative 14. We got the same thing. We divide both sides by 7, and we can show that by just kind of dividing everything by 7. We can kind of take care of it all together here, and that leaves us with k is greater than negative 8, and it's less than negative 2. So my solution set goes from negative 8 to negative 2, and I shade everything in between. Notice the boundary points are not included in the set. I don't have equal to here, so those are hollow points. And that's it. That's the idea. Nothing wrong with breaking it up into two inequalities like I did here, but it definitely can maybe save a little bit of time by doing it all together. Sometimes there's issues that happen by trying to do this all together. So just know that you can break it up if you need to. Okay. One more problem. A little blurry, but we'll go with it. This all-controlling machine operates when the humidity H satisfies the following inequality. We want to find the range of humidity values that the machine operates under. So here's our inequality, compound inequality, to let us know how the all-controlling machine works. One thing I might do is use the distributive property. Or I could notice that I could just divide everything by 2, and that doesn't really cause me any issues because negative 60 is even, and so I get negative 30 is less than or equal to H minus 50 is less than or equal to 30. And we're almost there. We've got these humidities down. I'm adding 50 to both sides. And notice we get a solution of positive 20 is less than or equal to H, which is less than or equal to 80. I'm not asking you to graph it, but of course, always good to think about what that would look like. I got 0 here. Here's 20. Here's 80. So we would have a filled in circle at the boundary point, since it could be equal to 20 and 80 degree, probably percent, whatever it's measured in, for the humidity between 20 and 80, and it could be equal to 20 and 80. All right, there's one more problem for you to do. Try it out. Please check with your partner. Make sure everybody that you're working with is understanding that last problem. If you're at home, check in with yourself, check your answer, and try the quiz out. Thanks so much for watching. Have a